Alrighty, everybody. Hello and welcome to the wolfSSL and Twin Oaks live webinar with our senior engineer, Chris Conlon, and Twin Oaks co-founder, Nina Tucker. My name is Kajal Subkota, and I will be moderating this webinar. As a reminder, all attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box or raise your hand to be unmuted if you'd like to ask the question live, as we will host a Q&A session following the presentation. This webinar will also be recorded and made available on our YouTube channel shortly after the presentation. I also invite everyone to follow us on our socials at wolfSSL and at Twin Oaks, and feel free to email us at facts@wolfSSL.com if you have any additional questions. And now I'd like to give brief company overviews before we move on to the technical presentation. So Twin Oaks Computing is a company dedicated to developing and delivering quality software solutions. Founded in 2005 and headquartered in Castle Rock, Colorado, their staff has over 45 years of experience in developing and supporting robust communication architectures. They leverage this world-class technical experience to provide innovative and useful communication software systems. Twin Oaks builds the software that collects, manages, and distributes information in a wide range of industries. Their CoreDX DDS software is in use around the world, supporting critical missions. CoreDX DDS is the leading small footprint DDS middleware available. Based on open standards for guaranteed interoperability and long-term viability, CoreDX DDS is a preferred IPC for a wide variety of distributed software programs, from mobile games and consumer electronics to surgical equipment, healthcare applications, complex DoD systems, and robots working in space. CoreDX DDS is an easy-to-use, cross-platform, cross-language inter-process communication library. It's high performance and low overhead with low latency support, real-time control, and high measure throughput to support high bandwidth data. CoreDX DDS provides secure, robust, flexible, and dynamic data communications. And CoreDX DDS is essential for effective open system architectures and the industrial Internet of Things. A little bit about Nina. Nina is the co-founder of Twin Oaks Computing and has the current responsibility for creating and managing customer and partner relationships. Nina has a strong passion for both engineering and education. She started her career with GE Aerospace, now called Lockheed Martin, in Valley Forge, PA, as an entry-level software engineer. Over the next 15 years, Nina worked on a number of programs developing and maintaining a variety of large and complex software systems in various technical roles, from system administrator to senior software engineer to software engineering manager. Nina has a BS in computer science from Pennsylvania State University and a master's in computer science from the University of Denver. And now a little bit about wolfSSL. wolfSSL was founded in 2004 by Todd Auscott and Larry Stefanik when they realized there wasn't an open source, dual licensed embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, and was equipped with a clean and modern API and offered commercial style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of almost 40 dedicated employees in 2021, most of which are engineers. This progress is, of course, supported by a strong partner network that we're very proud of, which includes Twin Oaks, STMicro, and Curl, for example. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO 178 support, FIPS certification, and a FIPS ready offering, MQTT up to the version 5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfboot, as well as Java wrappers and JSSC support and commercial support for curl. All of these offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I'm going to hand it over for the presentation. Alrighty, before we officially start, we have a poll question asking everybody, this is a little bit fun, asking everybody about their job title. Whether you're in management or you're all about code, or you're an architect, or if you find other people's mistakes, integration and test, or if you're still learning about a lot of things, which I'm sure everyone is. Yeah. Alrighty. We'll wait a couple of more seconds to allow everybody a chance to put their answers in. And I think that's everyone. Awesome, thank you so much. Here are the results from our poll question, just in case, everyone was wondering. It seems that most of you work in architect, so software, network design, etc., which is really exciting. Awesome, thank you so much.
All right, thanks, Kajal. Hello, everyone. My name is Chris Conlon. Kajal introduced me briefly. I'm an engineering manager here at wolfSSL. Today, we've got a kind of a brief lineup for you today. We're going to start off with some info about wolfSSL, an intro to our company and products, what makes wolfSSL different than some of our competitors, how we test wolfSSL to make sure we're ensuring that it's secure for our customer and users. And then we're going to lead into Twin Oaks as one of our partner companies. We have Nina Tucker, as Kajal let you know, here on the call with us today from Twin Oaks. And Twin Oaks is going to go through an intro to middleware and securing data communications, talk about the data distribution service and their CoreDX DDS, and then end with a little info about DDS Security and how wolfCrypt can be used inside of DDS Security as well. And then we'll have some time at the end for question and answers so we can get your questions answered. So be thinking of some as you listen to our content. So first off, kind of an intro to wolfSSL. wolfSSL was founded in 2004 out of the MySQL database company. At that time, MySQL needed a clean room SSL implementation. OpenSSL was available, but the license wasn't obviously clear throughout the code base. So we wrote our first SSL library called YASL. That was in C++. And between 2004 and 2006, we really kept hearing from the market, asking us, do we have a C library instead of a C++ library? And so we rewrote it again from scratch, this time in C, and branded that as CYASL. And then in 2014, we changed the name from CYASL to wolfSSL, just to better fit our company culture and naming across products. And so that's still our primary product through today. If we look at our company growth, we have over 1,000 commercial customers that use wolfSSL products today, and 17 partners that resell wolfSSL products. Our best estimate is that we secure around 2 billion endpoints on the internet today, and that number is growing year by year. This slide shows you our current product lineup. So our main product is wolfSSL. This is our SSL TLS library. Underneath wolfSSL, we have wolfCrypt. This is our cryptography library. And we have some validated and certified versions of wolfCrypt available for FIPS 140-2 and soon to be 140-3, DO178 for avionics. We also have an asynchronous crypto module, which can be used on the server side for users wanting to reach highly scalable TLS distributions. We have an MQTT client implementation called wolfMQTT, an SSH client and server library, a TPM 2.0 library, a secure bootloader called wolfboot, and our newest product this year is an embedded intrusion detection and prevention system called wolfSentry. All those products in the first row are written in C. We do have users that would like to use us from other languages. So we do have wrappers for Java with a JSSE and JCE provider, and just a thin JNI wrapper. We have a C# wrapper, a Python wrapper, and also a JavaScript wrapper. And then the third row here is a set of applications that we have available. We have an SSL termination proxy, a simple certificate enrollment protocol implementation, a secure update solution, a command line utility we call wolfclue. We do have the author of curl on board as a wolfSSL engineer, and so we provide commercial support packages and feature additions to curl. And we also have a version of curl that's meant for resource constrained devices. That's called tinycurl. All these products are dual licensed under both a commercial license and an open source GPL v2 or v3 license. If we look at wolfSSL a little bit closer, we do support up to the most current protocol standards of TLS 1.3 and DTLS 1.2. Footprint size of the entire library ranges from 20 to 100 kilobytes. That depends on build options and your compiler that you're using. Runtime memory is 1 to 36 kilobytes per session. And we've ported almost every RTOS and OS that we've encountered to date. You can see a list here on the bottom of this slide. That's everything from your standard Windows, Linux, Mac, through a number of different RTOSs down to a bare metal level. A couple additional features of wolfSSL. We have an OpenSSL compatibility layer. This includes roughly 1,000 of the most commonly used OpenSSL functions. And what we do is we have the same prototype as the OpenSSL function, but map that down internally to wolfSSL API underneath. And so oftentimes that allows you, if you have been using OpenSSL, to use wolfSSL as a drop-in replacement. We've integrated wolfSSL into a number of different web servers, including Apache, Nginx, Leidy, and Mongoose. One big differentiator for us is our support for hardware-based cryptography. And so if you're using a silicon part that has crypto built in, we can use that instead of using the wolfcrypt software cryptography. That'll give you performance increases of at least 5 to 10 times, and also code size reductions. We have a set of our API that we have marked and denoted as ABI compatible from release to release. And so that benefits users that want to do binary releases between wolfSSL versions. And then we're also NSA Suite B compatible. And like I mentioned, have our FIPS validations that we'll talk a little bit more in detail in a few slides. So wolfcrypt sits underneath wolfSSL, providing all the crypto primitives for wolfSSL or for other applications or protocols that also need to consume cryptography. This slide shows you all the algorithms included inside of wolfcrypt. These are all your standard algorithms, in addition to some more progressive ones like Cha-Cha 20, Poly 1305, and Curve-Ed 25519. And all the algorithms in red here can be used in FIPS mode with wolfcrypt FIPS. For those of you not familiar with FIPS, FIPS 140-2 and the current version, which is coming out now, is 140-3. This is essentially a requirement for Department of Defense or government projects that are consuming cryptography. Oftentimes, it's more of a checkbox item for federal agencies to purchase and use cryptography. We also have seen that several private and commercial organizations that are not operating in that space do also perceive an advantage when using a FIPS 140-2 validated product, just because of the extra testing that it's gone through and validation cycle. So the next couple slides here are answering the question of, why use wolfSSL instead of another competing implementation? We get asked this a lot. We have OpenSSL as kind of our big open source competitor. There's also some more, competitors that are more resource constrained oriented. And so, first of all, if we look at wolfSSL products, since the beginning of when we started, we've always been trying to build our products with portability, modularity, and performance in mind. So for portability, wolfSSL supports over 30 operating systems and RTOSs. We've tried to abstract out pretty much all system level dependencies, things like IO, logging, memory, anything that's going to need to change from platform to platform. For modularity, all of our algorithms and features can be compiled out on a per preprocessor basis. So that lets you customize and optimize your footprint size. And for performance, our team is continually working on optimizing performance. We know a lot of our customers are embedded with slower processors, and so faster performance can mean a lot to them. So we're optimizing both wolfCrypt software and when we're using hardware cryptography. The second item here is low memory usage. So we've tried to design our products with our resource constrained users in mind. If you compare our footprint size to OpenSSL, we're 20 times smaller. So that's obviously going to fit better into an IoT or resource constrained environment. And then mature and widely used. We were founded in 2004, so we have over 16 years of experience now, securing all kinds of products. We have worked with quite a wide range and diversity of products. So it's likely that we've already helped a customer in your application space or industry, which means we can most likely help you get up and running more quickly when adding crypto or TLS to your product today. wolfSSL does have a commitment to security and features. We're committed to keeping our products secure through doing excellent testing. We're committed to maintaining our feature set so we don't break backwards compatibility for our existing users. And then we're also committed to staying progressive in adding new algorithm and new protocol support. One of the kind of new algorithm things that's up and coming now is post-quantum crypto support. And so that's something that we're currently looking at adding. wolfSSL is well supported. We have all of our original code authors and engineers on the team today still. Our customers get support directly from those engineers. So this means we can help solve your problems more efficiently than someone who isn't quite as experienced in the code base. We have our certified and validated versions of wolfCrypt available. FIPS, like I mentioned on our previous slide, for DoD and government customers. NIST CAVP algorithm-only validations, which can be helpful standalone for several different reasons. One being helping with the common criteria process, and then DO 178C level A for avionics. And so one of the things we really like to put a lot of effort into at wolfSSL is our dedication to testing our software. We do think we provide the best tested SSL and TLS and crypto library available today on the market. And so if we take kind of a step up higher for a minute and look at, what is the importance of testing security software? First of all, it holds a critical position in your applications. Your applications using a security package are going to depend on that for things like data integrity, confidentiality, authentication, things that need to be done right, and there's not a lot of room for error there. Second of all, there's an expectation of security. If there's a lack of testing in the product you're using, that can easily allow vulnerabilities and crashes to get into your application. And then maturity and trust. Users must be able to trust security software. And the more mature that security software is, the more confidence you will have as a user in the code quality of the product you're using. And so taking that into mind, we're always adding new types of testing to our test environment for wolfSSL. This slide shows you some of the types of testing that we're currently doing. So we do everything from basic API unit testing, testing our cipher suites with different protocol levels, doing algorithm testing with RFC vectors and also our FIPS CAVP vectors, doing benchmark testing to make sure we haven't slowed down the library, doing static analysis with tools like Coverity, ScanBuild, and Facebook's Infer tool. We detect memory errors, making sure we don't have memory leaks with Valgrind and with Klang's fsanitize address. We do interop testing against all the major implementations of SSL, TLS, and crypto around and widely being used today. We do real world builds. So this means we're testing our own customer builds on a nightly configuration basis. And so we're not breaking our customer builds from night to night. We do compiler testing with several compilers, both embedded and desktop oriented. We do peer review on every single line of code and every PR that makes it into our repositories. We do third-party testing from customer labs, academia, and through our validation processes. Fuzz testing, we started with a couple when we first started. Now we have over 6 different fuzz testers that are continuously fuzzing our code base to try to find essentially try to find crashes so we can fix that to return error instead of causing a seg fault or a crash. And we wrap all that up into a continuous integration cycle using Jenkins. And so, as you can see from the last couple slides, wolfCrypt especially can easily provide building blocks to create higher level protocols or use in applications or middleware. Twin Oaks that we have with us today is one of our partner companies that uses and leverages wolfCrypt in their DDS security product. wolfCrypt can be used as an alternative to OpenSSL, and essentially you as a customer can gain all the benefits that we were talking about in the previous slides, along with seamless integration with DDS Security. So now I'm going to turn it back over to Kajal for another poll question.
Awesome, thank you, Chris. Our second poll question is more about architecture. How much architecture are you and your group responsible for? Greatly appreciated if you could answer. From like data design, model, and data stream behaviors to plugging into an existing network with already defined data topics and with data topics in QoS, part of new architecture, but not responsible for any design, or already designed my system and now wondering what I missed, or you're just here to learn. Going to allow a couple of more seconds so everyone has an opportunity to answer. Okay, awesome. Thank you so much. It seems that people either are here to learn or are designing data models and data stream behaviors from scratch, which is really interesting to know. Awesome. Okay, thank you, Chris. Back to you.
Okay, I think this is my turn to jump in. This is Nina Tucker from Twin Oaks Computing. Thank you, both Kaja and Chris. Chris, that was a great introduction to wolfSSL and wolfCrypt. And now I want to talk about communications middleware. So I'm going to start with some examples of connected systems and kind of the challenges that are addressed by middleware. So aerospace and defense. This industry has a number of complex network software systems, including anything from sonar command and control, C4ISR, ground stations, air platforms, autonomous boats, vessels, land vehicles, and rovers on the moon. So what are some of the challenges of connecting these systems? Well, these systems are heterogeneous. Some components are new, some were built 20 years ago. Components span a variety of hardware architectures, operating systems, RTOSes, and even programming languages. These systems have specific requirements for data communications, including strict timing data streams, reliability, robustness. Some systems contain less than ideal network infrastructures with low bandwidths or very high latencies, or embedded network stacks with various limitations. And removing stovepiped architectures and opening up system interfaces is an ongoing effort within defense programs in order to reduce costs. A large part of this initiative includes standardizing connections and interfaces within systems. All right, switching over into data acquisition and instrumentation. Here, this industry is focused on the general challenge of collecting a large volume of sensor data in a short amount of time. One example is an aircraft engine testbed where various sensors for things like temperature, pressure, vibration are placed around and inside the engine to collect data as the engine is running. And on the small scale, there might be 8 or 16 sensors collecting information at 10 hertz. And on the large scale, like testing a large jet engine, there may be hundreds or thousands of sensors collecting data anywhere from 1 hertz to 20 kilohertz. And many of these data streams must be processed in real time in order to detect issues that require immediate responses. Okay, and finally, in the medical industry, well, there are a wide variety of connected systems here, including surgical tools that are connected in the operating room, home monitoring tools that are connected to doctors' offices, and wearable medical devices, and the large-scale collection of data used from all of these deployed systems. And each of these medical use cases has their own networking challenges. These include complex installation configurations in hospitals, connecting components with a diverse set of processors and operating environments, and the security and confidentiality requirements levied by the FDA. All right, so what is middleware? Communication middleware is the infrastructure software that handles the transfer and delivery of application data and takes care of all the underlying challenges, like the challenges of our defense and instrumentation and medical projects, to make that communication happen. All right, if there's any experienced software engineers in our audience, you probably know what I'm talking about. It's one thing to create an application that uses a simple socket connection to transfer data, but then what happens when you need to worry about the availability and robustness of that connection? What if the other end isn't there yet? What if it restarts? What if my network drops or is congested, losing data packets? What if I need to connect, say, a Java application on an iPad with a deeply embedded ARM device running ThreadX and some Windows display components? These are some of just the very basic challenges of any connected system. Communication middleware handles these challenges and maybe even add some additional features like timing contracts or levels of reliability, filtering, and security. Now, while this diagram that you're looking at is extremely simplistic, we can think of it as showing a connected system with edge devices, sensors, actuators, operating in and on the physical world. These are connected to other system components, maybe servers in the cloud, maybe other concentrators or controllers somewhere in the middle. Let's say that this picture represents the design of a connected system. A bit of middleware will reside in every connected system component, handling the details of data communication between those components. And this represents the system operating in the real world. In today's systems, with their additional connectivity, the majority of cyber threats attack the networks, the connections between software components in a system. And these attacks are things like man in the middle, eavesdropping, denial of service, and other network-based attacks. It really doesn't matter if the endpoint is a Windows machine or a PLC or a microcontroller. If it's connected to a network, it has vulnerabilities. Now, there are some common cybersecurity elements that provide the foundation for secure data communication, including DDS Security. And these are the elements used by DDS and provided by the wolfSSL software. Now, first is identification and authentication, or simply INA. Now, when we interact with each other, we identify ourselves all the time. I might say, hi, my name is Nina Tucker of Twin Oaks Computing. Now, the question is, do you trust me? Well, maybe if we met at a technical conference, that's enough. But if you're getting ready to say, trust me unsupervised inside your house or allow me to board an airplane, you might want more confidence, in particular, some form of trusted authentication, maybe like a driver's license or a passport that I am indeed who I say. Now, this concept, when you apply it to computer systems, is identification and authentication. A component of the system is issued a trusted identification certificate, that's akin to my passport, and that identification certificate is signed by a trusted certificate authority, like the government agency that issues my ID. This prevents unauthorized devices from listening to messages, discovering the types of data, and also prevents any device from connecting to the network pretending to be a valid component. Next is access control. Once I've been identified and authenticated, what am I allowed to do? In these systems, each device or component involved with communications has a set of permissions. What data exactly it's allowed to publish, what data exactly it's allowed to access. And this reduces the risk of friendly attacks on known authorized components from attacking the system, whether that's intentionally or unintentionally. Now, integrity ensures data is not changed en route from sender to receiver, preventing data from quietly being tampered with on the wire, and confidentiality prevents data from being seen or discovered by unauthorized components. Now, these four elements, INA, access control, integrity, and confidentiality, are the common security elements addressed with securing data communications within a connected system. Okay, so now let's talk about the Data Distribution Service, or DDS. The Data Distribution Service is a data communications middleware standard that is designed specifically for dynamic, distributed, and decoupled systems. Systems like the examples I mentioned earlier, where the number of components may change, data use may evolve over time, and additional value will derive new requirements and features. These systems are distributed from the edge, where command and control is affected by current conditions, all the way to the cloud, where data analytics are performed for things like predictive maintenance and continuous process improvement. And components of these systems can, and in many cases, must operate independently and in the absence of other components. Now, DDS provides a peer-to-peer architecture that is inherently decoupled. It doesn't depend on brokers. It can be deployed without any single point of failure in your data communications infrastructure. DDS automatically handles network disruptions and other anomalies, resulting in an extremely robust system. DDS is scalable from component level on the edge to enterprise systems in the cloud. The protocols and APIs are available for bare metal DSPs, PLCs, microcontrollers, for your higher level SoCs with real-time operating systems, mobile devices, and of course, standard computers and servers. And DDS is secure. Now, one of the unique benefits of DDS security when you compare it to other middleware security solutions is that DDS security maintains all of these really nice and useful features of DDS while still providing state-of-the-art security protections. Now, I mentioned that the Data Distribution Service is a standard. Actually, it's a group of standards. And CoreDX DDS is the Twin Oaks computing product that implements those DDS standards. Here's a very quick look and high-level look at some of the features specific to CoreDX DDS. First, CoreDX is a very small footprint. We include all the standardized features of DDS into a smaller package. That's smaller library sizes, fewer dependencies, and smaller runtime resource utilization. Also, DDS, or CoreDX DDS, is robust. We continuously improve the robustness of our implementation across all kinds of target execution environments, from connections with large latencies, dynamic networks, high loss networks, very embedded components. We've deployed and optimized CoreDX DDS in all kinds of environments, including a lot of those target combinations that you saw on one of Chris's earlier slides. And CoreDX DDS supports the use of wolfCrypt to meet the DDS security requirements, giving you tremendous flexibility and robustness in your secure communication streams. Now, I'm really excited for this partnership between Twin Oaks Computing and wolfSSL. And one of the reasons is that we have this similar approach to both the development of our technical products, where we're both targeting a small, lightweight, portable, robust infrastructure component, and then also our commitment to our customers. It's really going to be exciting to see what we can accomplish. So CoreDX and the DDS technology is found in a growing number of mandates, industry standards, and high-level system requirements. Here are just a few examples, and there are many more. If you're familiar with DDS, you may have been introduced to the technology through one of these groups or architectures, or because of your customers' requirements. The DDS specifications remain relevant and attractive in a wide range of industries, and this is because of a combination of the full standardization of the DDS technology that allows system architects to define interfaces in an interoperable machine-readable format, and the vibrant community and interactions between the people developing system requirements, the people developing individual components, and the vendors of DDS products. All right, let's go into some of those specific features that make DDS and CoreDX DDS attractive to system designers. Now, first, DDS reduces development effort. Remember those basic networking challenges? Without a middleware like DDS, your application is responsible for all of this networking in addition to your own functional requirements. With CoreDX DDS, your engineers focus on your domain-specific software and leave all the complex bits of data distribution to the middleware. That's less code to write, less code to test, less code to maintain. And next, DDS makes your system flexible. With CoreDX DDS, you're not configuring IP addresses or port numbers. Rather, the automatic discovery process takes care of finding all the communication endpoints and appropriately connecting them. This is dynamic, so components can come and go during execution, and DDS will continue to find, connect, and disconnect as necessary. This means adding new components to your system doesn't require specific DDS configuration. And related to both of these is the maintainability of your system. With less code to manage, with the ability to easily add, move, or remove components from your system, it makes it easier to maintain. With lightweight protocols, dynamic discovery, and a support for a wide variety of operating environments, your system is easy to extend and scale. You can add CoreDX DDS into embedded devices, sensors, actuators, real-time components, servers, and backend components, connecting all aspects of your system with one protocol. And finally, security is built into the DDS protocols, adding those standard security features of authentication, access controls, integrity, encryption, and logging. All of these features add up to a system with less development risk and a faster time to market. All right, so DDS Security is one of the more exciting standards in that family of DDS standards. DDS Security defines a flexible and scalable peer-to-peer security solution that's fully integrated into the DDS protocols. This is not just using a TLS connection for communication, but rather it's a comprehensive cybersecurity solution for data communications. Now, DDS provides a number of benefits that allow for open architectures, flexible decoupled systems, including automatic and dynamic discovery of communication endpoints. These same benefits can allow rogue publishers and subscribers to join the DDS network and unauthorized packet sniffers to listen in on data communications. The DDS security standard was created to address these vulnerabilities, allowing the system designer to require participants to be identified and authenticated, enforcing access controls for those authenticated participants, and encrypting data streams so they are unavailable for rogue subscribers. CoreDX DDS security covers all aspects of secure communication, and each of these security aspects is fully configurable. Now, because security features are integrated into the DDS technology, users still experience the same benefits of DDS's dynamic discovery, scalable architectures, and configurability. All right, let me talk just a little bit about DDS configurability. DDS, through what are known as quality of service policies, provide the ability to configure the behavior of individual data streams. Distributed systems are dynamic and they have different specific data communication patterns. One is real-time command and control. There might be streaming sensor data, tight feedback loops, maybe large amounts of data for analytics. And the data distribution service is well suited for all of these data communication patterns because of the rich set of quality of service policies specified by the standard, which may be applied differently to each stream of data in your system. Now, similar to those quality of service policies, DDS security allows configuration of security characteristics for individual topics. Some data streams may be configured with integrity checks, some with encryption, and some with neither. Now, in contrast, other communication middlewares provide security controls at the transport level that applies the same controls to every stream of data in your system. Now, CoreDX DDS Secure contains an implementation of the standardized DDS security plugins. These plugins control the secure aspects of DDS communication. That's the authentication, access controls, cryptography. The actual security algorithms are contained within the wolfCrypt library. You can see some of those wolfCrypt security algorithms that are used by CoreDX DDS on this slide. And it's important to note that because these security plugins are defined by the DDS standards, they're interoperable. So those medical, instrumentation, and defense applications I talked about earlier, they're not locked into a particular DDS product for their entire system. Rather, they can design their system to the DDS standards, and all the individual manufacturers of components can select any DDS implementation that complies with those standards. Now, because cryptographic security features are built into our DDS products, CoreDX DDS users don't need to worry about specific configuration for wolfCrypt. In fact, system developers using CoreDX DDS can design their distributed application independently of the security design of the system. Now, during design and development phases, engineers will develop applications using the CoreDX DDS APIs. And this includes designing the topics, the data types, and the quality of service configuration of those topics. If using DDS Security, these applications will contain hooks for the security configuration, which will be applied at runtime. The application will be linked with both the CoreDX DDS library and one of those wolfCrypt libraries that Chris mentioned earlier. Independently, security architects and engineers will develop the system security plan, including security for data communications. This will include using wolfSSL tools to create certificate authorities and identity certificates, and developing the DDS security plan called the domain governance, which specifies which topics will be encrypted, if the metadata will be secured or just the application data, and where access controls will be applied. When this DDS-enabled application is run, it must be initialized with its identity, with the identity of its certificate authorities, and with the DDS security configurations for this particular test or deployment environment. Okay, well, this concludes the technical portions of the presentations. Thank you all for your time and attention. If you haven't gotten your questions in yet, please do that now. We'll try and cover as many of them as we can. And I didn't have time, Chris and we didn't have time to get into too many details, but I hope this presentation provided a good introduction to wolfSSL, their crypto technologies, and the DDS technology and CoreDX DDS products from Twin Oaks Computing. Today's connected systems have complex communication and security requirements. And while the specific requirements can vary, the common challenges of flexibility, scalability, robustness, reliability, and security are fairly common across them all. CoreDX DDS and wolfCrypt take care of the network communication details so you can focus on your functional requirements. Okay, Kajal, I'm going to hand it back over to you to field any questions that we might have.
Awesome. Yeah, thank you so much. And as a reminder to everyone, please feel free to use our Q&A box to ask any questions, or alternatively, you can even raise your hand and you can be unmuted and ask the question live. We have a couple of questions here. Is there a way to integrate the Twin Oaks DDS security plugin in another DDS solution instead of the provided DDS secure plugin?
Yeah, okay, that's for me certainly to answer. That's a really interesting question. The standards were designed to allow exactly that, to allow different plugins to handle those security aspects for DDS to be plugged into a DDS solution. And I think the original thought behind that was there may be some systems and some projects where they want to develop their own cryptography sort of functions. And so there's this standardized API of how to plug those into a DDS product. That being said, that's probably a feature that hasn't really been tested. While we test a lot of interoperability on the wire, each DDS solution is using their own implementation of those standardized plugins. So I don't know that there's been a lot of testing of that plugin API between the security modules and the DDS product itself. If you're talking about taking like a Twin Oaks computing plugin and plugging it into like an OpenDDS security solution, that we haven't really explored very much.
Okay, awesome. We have another question here. Does the DDS initialization also include secure boot?
All right, that's an interesting question. I'm going to start on this one, and then I don't know, Chris, maybe you can jump in if you've got a little bit more insight. So when we're talking about DDS as a communication middleware, it's not part of the boot process at all. If you think about DDS resides inside your application software. So that's going to be sitting on top, like once the OS boots up and starts executing applications, one of those applications it executes is going to be your application containing CoreDX DDS and wolfCrypt code inside of it. So that's really separate from the system booting up. And that being said, Secure Boot is probably one of those services that is provided by the wolfSSL suite of products that you can take advantage of.
Yeah, that's right, Nina. Like you mentioned, the crypto algorithms are separate and typically would be in the application layer, but we do have a Secure Boot product that we call Wolf Boot, which could be used and helpful for Secure Boot if that was needed.
Awesome. Thank you so much. We have another question here. What is the maximum bandwidth supported, and is there any overhead on the bandwidth due to middleware?
Oh, that's another great question. So this talks a little bit to the performance of the middleware when we're talking about data transfer. In general, the DDS standards really specify lightweight communication mechanisms. That means that the application data is going to be put into a compressed binary format. We're not sending like XML strings over the wire, right? We're sending it in a binary representation. So in general, those standards are thinking about lightweight sort of communication mechanisms. Now, that being said, it's really up to the individual developers of those products, like us developing CoreDX DDS, to really take advantage of those and further improve or optimize network performance. So I know if we're talking about our product in CoreDX DDS, there's really no maximum bandwidth. It's just a function of what your bandwidth is. So I know we've run CoreDX on everything from like a 1 megabit link or even down to like a 100K link, all the way up to like a 10 gigabit sort of fiber network. And if you look at the bandwidth of the actual data over using the DDS protocols, it really scales pretty well. Where you're going to use something like 90-ish% of the available bandwidth is going to be used for your application data, with, of course, a little bit of overhead for the middleware, because we are doing things like maybe some filtering, finding the endpoints, checking on reliability and doing retransmits if necessary, right? There is a little bit of overhead within those DDS technologies, but it is fairly lightweight. And like I said, there is no maximum. If you have a very fat network pipe that you can put a lot of data through, DDS will support that as well.
Fantastic. Is there an Android version of CoreDX with DDS Security inside?
I want to say that we have. I'd have to actually go look and just double check that we have built that. But I'm fairly certain that we do have people using Android with CoreDX DDS and DDS Security. It's one of the reasons that we really liked wolfSSL. And before this partnership, we've actually been kind of working I want to say not formally, but informally with wolfSSL. And one of the reasons that we really liked it from a middleware perspective is our CoreDX DDS goes on all kinds of different operating systems, including mobile devices. And wolfSSL was one of the places where we could go to get this crypto library that supported all of the same platforms that we did. It didn't require us to go and try and build something or try and make something fit in it. I don't remember, and I don't know if you remember, Chris, is Android one of your supported platforms?
Yeah, wolfCrypt definitely will run on Android out of the box. So we've got some examples for that, and if needed, can help get it working there.
Yeah, and as long as if that's all we really need, because we build against the wolfCrypt APIs. So as long as that wolfCrypt library is available, it's just a matter of building it and running through tests. There's really no additional integration. But I honestly want to say that we do already have that available. Like I said, I just don't remember off the top of my head.
Awesome. We have a question here. Does DDS interoperability extend to the cryptography? That is, can DDS secure applications using OpenSSL communicate with CoreDX DDS using wolfSSL?
Yeah, you betcha. I did talk about interoperability, but one of the really interesting things about interoperability is it does extend to the crypto library. So the way that CoreDX DDS makes use of these crypto libraries means that you can use CoreDX DDS with Wolf Crypt library, and you can have that interoperating with another DDS application that maybe is using OpenSSL, and they will interoperate. They will automatically find each other and do the appropriate securing, authentication, and exchanging of data.
Awesome. Can you provide some examples of embedded environments using CoreDX DDS and WolfCrypt? Yeah,
you betcha. Like I mentioned before, I think it's kind of how we got started. Twin Oaks Computing got started with wolfSSL. I'm thinking the first time we used it, it might have been an Integrity 178 platform where somebody wanted to use DDS Security in that environment. And of course, you're not going to be able to get OpenSSL in there, which is where we ran across wolfSSL on their WolfCrypt library. So I know we've used it on those kinds of safety critical RTOSes. But we've also used it down like free RTOS. We've got some free RTOS implementations that are using a WolfCrypt library, again, targeting free RTOS with some kind of low performing ARM processor with just a little bit of memory running in those kinds of environments. So you really do have flexibility to put CoreDX DDS and wolfSSL in all kinds of different operating environments.
Awesome. And I think that was the last of our questions. I'd like to thank Nina and Chris for a fantastic webinar. Oh, we got one more question right here. Are all DDS security algorithms FIPS 142/3 validated when using WolfCrypt?
Yeah, that's really the beauty of the APIs that we're using, right? Is that set of APIs that CoreDX DDS or DDS Security just in general uses are ones that wolfSSL has certified in all of their FIPS versions of WolfCrypt. So that's really the nice part. You as the application designer don't really have to worry about how do I fit in this FIPS requirement. You can pick up CoreDX DDS, you can plug in the right WolfCrypt library to meet your requirements, and there you go, you're all set.
Awesome. Okay, now I think that was the last question. So thank you, Chris and Nina, for a fantastic presentation. Thank you, everybody, for attending. As a reminder, this webinar is recorded and will be made via our YouTube channel at wolfSSL shortly following the presentation. If you would like to receive a slide deck, perhaps, you can also send us an email at facts@wolfSSL.com, and we'd be happy to send that over to you. And if you have any additional questions, please also feel free to email us at facts@wolfSSL.com, and we'd be happy to answer. And follow us on all of our social media at wolfSSL and at Twin Oaks. And I hope everyone has a fantastic day.